We're now going to go through the change of base law. So the change of base law. Let's begin by looking at this right here. So here we have log of base a of x is equal to 1 over log of base x of a. So hopefully you can see what's happened here. Our base has become our argument, and our argument has become our base once we go 1 over our log. Okay, so how on earth does this work? We will go through a strict proof later on in this video, but for now, I just want to demonstrate using log of base 2 of 8 to demonstrate that this law is true. So if I have log 2 of 8, I know that that's equal to 3, don't I? Because 2 raised to the third power is equal to 8. But I want to use this new law that I've learnt. So log 2 of 8 is going to be equal to, according to this law, 1 over log, and then we're going to swap these around. So this will be 8 and this will be 2. Now let's think about it for a second. This denominator, what is it telling me? I'll put a little asterisk here. It's telling me 8 raised to the what power is equal to 2. And we know in order for this to work, x would have to be 1 on 3. Because if I take the cube root of 8, I get 2 out, or 8 raised to the 1/3 power gives me 2. All right, so that means I can come here and I can go 1 over 1 on 3. How many times does a third go into 1? It goes in 3 times. And do you see how I've gotten the same answer? So this and this are the same. So that's a demonstration of the change of base rule. It's not a proof. We'll go through a proof later on in this lesson, but it just gives you an idea of why it works. So this is something that you can apply. Okay, let's go through a slightly different version of the change of base rule. It's exactly the same. It just looks a little different, and I'll show you how this is connected to what we saw over here. All right, let's give it a go. So here again, we're being told that log of base a of x is equal to log of b of x over log of b of a. Okay, as you can see, here's my base, and there it is here. And then here is my argument, and here it is here. And then we've also got a base b in each case. Okay, what's happening here? Well, let's use log of base 2 of 8 to demonstrate this, and we're going to have to use our cas as well. So this law is telling me that if I have log of 2 to the 8, it should be equal to log of... Now, here's the important part. It doesn't matter what we make b. b could be anything. Let's make it 7. Log of base 7 of x, so that would be 8, over log of base 7. Now we're going to make this 2. So hopefully you can see what we've done here. The base becomes the argument of the denominator, and the argument becomes the argument of the numerator. Now we need our cas to answer this, so we're going to come over here now, and I'm going to go control this one, then I'm going to go control that one, then I'm going to go 7, 8, then I'll come down, and I'm going to go control this one, and I'll go 7, 2, and I'll go answer, and I get 3 out. Would you look at that? We know that's the answer. And let me prove to you that it doesn't matter what we make this base here. As long as it's the same, it doesn't matter. So let me show you another one. Let me show you what would happen if we went log of base. Think of a really weird number. Let's put in 91. 8 log of 91, 2. All right, so now we'll come up here and I'll make this 91, and I'll make this 91, and I'll get 3 out. So as you can see, it doesn't matter what we make that base. As long as it's the same in both the numerator and denominator, we will get our answer. Okay, now how is this connected? Like, how are these two things related? Like, there's obviously some sort of relationship. They're both called the change of base law. How are they related? Well, if I get to choose what it is I make my base, why wouldn't I make the base the same as the argument of the numerator? So let's make it 8. And then down the bottom, I'll make this 8, and I'll make this 2. Now, the reason why I'm doing that is because now that this is the same as this, and let me just get the colors all the same. The colors are very important, you know. 2. Whoops, and I've forgotten one more. Okay, so now, because I've made it 8, and the reason why I've made it 8 is because I know that log base 8 of 8 is going to be 1. 8 raised to the 1 is 8. And now I can write it like this. And this here is, let's see if I can do a nicer arrow than that. This is this. We've just chosen to make the base the same as the argument of the numerator. So that's kind of the thinking behind what's going on there. So this is the change of base law. All right, let's stop here for a second. And in the next part, I'll go through the proof of this.